go over those. Okay, so here's the review portion of the assignment. The first 2 pages, I think, were chapter review. So number 1, 2, and 3 were just simplifying your ratios. Let me zoom in on that. So number 1 should have been 3 to 5. And remember, you'll write that, just that format, just like that on your test. It'll be 3:5. And then 2, 4, 5 is your extended ratio. And number 3 is 2y over 3x. Number 4 says the measure of the angles in the triangle are 4 to 4 to 7. So you had to do 4x plus 4x plus 7x equals 180 to get x, and then plug that back in, and you would have gotten 48, 48, and 84. Are we good on that one so far? All right, then came, is the equation equivalent to the proportion? So what can I do to manipulate that proportion? 5 is no. You can't multiply straight across. You can cross multiply. 6 is yes because it's the reciprocal one. 7 is yes because of the cross multiplication or the cross product property. And then 8 is yes because they actually took away the denominator from, or no, they added the denominator to each one. So again, questions like that on your test, you're going to get given the left side of that proportion. You've got to fill in the right side. Number 9, the order of the letters is important. Remember, so where the B is the J. Number 10, FG over RS would equal GD over SP. Number 11, they give you the scale factor. So you just had to do 5 over 3 equals and then set up what you're missing. So BC is the 20. It would have been 5 over 3 equals 20 over X, and then cross multiply divide, you get 12. And B, if the perimeter is 30, remember the ratio of the perimeters is the same as the ratio of the sides. So it would be 50 for the perimeter of ABC. Good on those? Okay, 12, you had to figure out what your scale factor was this time. It's kind of turned sideways, so it's not necessarily in the same orientation that you're used to. The 8 matches the 12, so that would be your scale factor 8 to 12 or 2 to 3. And then set that up with the other ratios, and you should get x equals 9 and y equals 13.5. Number 13, RTS would equal UVH, and that's the angle-angle similarity postulate. 14, RT would be over UV, TS would be over VH, and RS would be over UH. And again, those letters could be reversed. So VU is the same as UV. And then 15, it says suppose you wanted to prove that RS times UV equals RT times UH. You'd first use similar triangles to show that the sides are proportional. So RS over UH would equal RT over UV. And then if we wanted to get to that next step, if I wanted to go from here to here, that would be the cross product property. So if you were to use this in a proof, that would be that next step. This would be definition of similar triangles, because if they're similar triangles, then the sides are proportional. And then that next step where you actually cross multiply would be the cross product property. So you always want to kind of think of, in terms of proofs, what would that look like? Sure. So the ratio of the side length is going to be the same as the perimeters. If I were to take and add up the ratio of all the three sides that were in the same ratio, it's actually going to be the same as the perimeter. So once you set up your scale factor as 5 to 3, and then you have the perimeter of JET, which was the second or the bottom. That goes in the bottom. So 50 would go in the bottom. Or sorry, 30 would go in the bottom. And then the X goes in the top. That's what you're missing. So if you, and I think it'll mention a little bit later in the book, but if you add up all the side lengths of something that's proportional, it will continue to be proportional. So if the ratio of the perimeter, if the ratio of the sides is 5 to 3, so is the ratio of the perimeters. It's also 5 to 3. And then from there, you would just cross multiply, or realize that you just have to multiply by 10 here and here, and that's where that 50 comes from. Okay, second page on the review was your triangles being proved by angle, side angle side, or side similarity. So 16 is yes and it's angle similarity. 17 is yes and it's angle similarity. 18 is yes and it's side angle side. And 19 is no. It does give you the side information, but they're not proportional. 21 says which one's incorrect, and it is number 2, SV over TW equals OS over ST would be wrong. So in a situation like that, maybe you want to set up all of your proportions and then just see which one doesn't match. The test will work the other way around. It's going to ask you to actually fill in a correct proportion instead of identifying a correct one. 22 is 25 and 23 is 14.4, which you'll actually leave in terms of, like on your test, you'll leave it in terms of an improper fraction, which would be that 72 over 5. That's how the format will be on that answer. That was your triangle proportionality theorem. And then 24 is 12, and that's your angle bisector one. So all that work is there on the bottom. Messy, but it's there. 24. So when you set up, it says in triangle ABC, the bisector of angle B meets AC at K, right? So you draw yourself a triangle, A, B, C. Bisector of angle B, which would be over here, meets AC at K. So that's the labeling process of it. Then it says AB is 18. It says BC is 24. And AC is 28. Find AK. So AK is my X. When you're dealing with the angle bisector, the triangle angle bisector theorem, you can't do like part to whole and part to whole, which is what's happening here. You have to break those up individually. So if I were to look at this side here being 28 and this is X, this little piece here would be 28 minus X. And then once you set that up, you can set up your proportions. So there's a bunch of different ways you could do it. I could do top to bottom, like 18 over 24 would equal top to bottom, which is X over 28 minus X. Or you could go left, right, like X over 18 equals 28 minus X over 24. The benefit of that first one is you can actually simplify 18 over 24, right? 6 goes into both of those, and that would be 3/4. Good morning, sunshine. So I'd get 3 times 28 minus X equals 4X. And then distribute here. That's 84 minus 3X equals 4X. 84 would equal 7X, and X would equal 12. So you've got to break that side apart when you're dealing with an angle bisector. When you're dealing with the triangle proportionality one or the parallel lines, you can say part to whole, part to whole. But with the angle bisector one, it's not as easy like that. He's in the playroom. Any other questions from the review portion? Okay, so what I'll give you is I'm going to give you about 20 minutes. So I'll edit that time on there, which is, we'll say that that's like 8. I'll give you till 8:35 to get the test part of this done. I'm actually going to remove this submission because I'm going to go over the answers on it. So don't worry about submitting it. Just make sure that it's completed by that 8:35. If you need to get yourself something to wake you up during that time, you can use it too. If for those of you, I think there was 2 of you that actually finished both parts of it. If you just want to open up the warm-ups for 7.4, 7.5, and 7.6, you can work on those for a little bit. All right, so I'll give you a break. I'll stay on, but you can check back in if you want to go grab a snack or breakfast or whatever, cup of coffee. I'll give you till 8:35 to get the chapter test portion also done. And again, if you've already done that, then you can open up the 7.4, 7.5, and 7.6 warm-ups and get those started. All right, ladies, enjoy your 20-minute break. Yep. Yes. Here, let me go back to it. Number 1 said two sides of a rectangle have the lengths of 20 to 32. Find in simplest form the ratio of the length of the shorter side to the length of the longer side. So really pay attention to the order of the words there, because if it's asking for a scale factor, it's going to be specific of which order it wants. So this is shorter to longer, which is 5 to 8 for A. And then remember, the perimeter is the same, but this time it says the perimeter to the length of the longer side. So perimeter, if it's a rectangle, you can add up the sides and figure out what the perimeter is, and then the length of the longer side would be that 32. And then just reduce it from there. 2, order of letters is important. U matches C, and BC over HU would equal AD over TS or ST. 3, X should be 20, Y should be 30. 4, X should be 13 1/3. Actually, the way it will be entered into it, this would be 40 over 3. So just keep that in mind, that on your test, you're going to write it as a improper fraction. And then 15, the bottom would be B, and the top would be C plus 10. 6 is angle similarity. 7, the missing part there is VN or NV. 8, angle VBA should equal angle NKV or VKN, same thing. So this could also be NV. The letters can be switched. You can even use K on that, because it's the only, like angle K would have been fine too, because that vertex is not shared. 9, scale factor is 5 to 8, so the missing side should be 4. 10, missing side is 9. 11, missing side is 20. 12, missing side is 39. 13, EB is 11.2. So GK is 5, KB is 8. This is 7, and this would be your X. So I can do 7 to 5 equals X over 8. 56. So it would really be X equals 56 over 5 is how that should have been written. Well, not should have been, but that's how it would be formatted on your test. 14 is 12. And then 15, proof. This one's easy because you can use the proportional segments that are formed by the parallel, but you could have done it a different way. So this one just said, given that they were parallel, if they're parallel, they divide them proportionally, and then you can cross product or means extremes property for that last step. 16, they gave you the two sides, or actually they gave you all four sides. You had to use vertical angles, so this missing step is that they're vertical angles. Then the sides are proportional. So then the triangles are congruent, side angle side. And then angle A would equal angle D because similar triangles have congruent angles. And then if A equals D, then those two lines are parallel, and there's your transversal because of alternate interior angles theorem. Or alternate interior angles converse, actually, is what that would be if you used its name. All right, questions? All right, I'm going to give you a 20-minute break. Do whatever you need to do to get your self ready for your test. So again, 9:35, come back to me, okay? If you want to get a snack, you want to look over your notes, whatever you need to do, and then at 9:35 we'll practice that. We'll get set up for your test. So when you come back on 9:35, make sure you're on a second device so that I can see your workspace. Make sure you have your notes ready if you want to use your notes, and then we'll take the test then. Everybody good? Any questions before I set you free? Okay, so meet back here 9:35. Jamie, I'm going to give you a break till 9:35. Why don't you get up and move around, okay? Because you're going to come back, take your test. 935, yep. Okay. All right, so this is 7-4, which again, just the angle similarity was in 7-4. So 2 is similar, 4 is similar, and 6 is similar. They'd all be angle. 2, you had to like subtract the third one to find that missing one. 4, you've got two sides marked as congruent, which means the two angles are marked as congruent. And then the similar triangle on the 6, it's got a reflexive angle and it's got the right angle. 10, you want to complete your statement. So I said this yesterday on an example like this. This is a really good example of something that you could see on the test. The order of the letters is important on your triangle. So A has to be M, L, K. B, M, L is in the bottom, or L, M, that could be reversed. And then M, N, and L, N. C, the first question mark should be 20, second one should be X, third one should be 20, fourth one should be Y. So you're just setting up those proportions. And then D is if you actually solve them, 24 is X and Y is 16. Everybody good on that one? Okay, 12, X is 9 and Y is 6. Remember the trick about the 12 one is when you're solving for Y, I could say 4 to 2 equals Y to 3 for Y. But when I go to solve for X, because it's not one of the sides that's divided, I have to do the top triangle, which would be 4, to the whole triangle, which would be 6, would equal the top triangle's bottom, which is 6, over the bottom triangle, which is X. Number 14, A is triangle ACD and triangle CBD. Again, order of the letters is important there. And B, X is 15 and Y is 9. Any questions on that page? How'd I do what, the order? Or the X and the Y? Okay, so once you figure out like what your triangles are, if you're looking, there's one triangle in which I have all the side lengths, which is that one, right? The pink one. And then if I want to find the missing sides of the big one, let's say I want to find X, that's one of the big ones, right? So X is the smallest side of the big triangle. I have to match it with the smallest side of the pink triangle, which would be 12. So I would do 12 over X equals, and then I got to get the ratio, right? So the smallest, well, when I look at the sides on here, because they're all proportional, I got to just set up one of the ratios. So if you look at the two smaller triangles, because if I look at the blue one and I look at the pink one, you could do it there too, but the 20 is the largest side of the pink one. The largest side of the blue one would be 16 and Y, and that doesn't have a match, right? So I need to find two sides in which they both have numeric values. So if I look at the 12, for example, is the middle side of this right triangle. The one on the right, the yellow one. 12 is the middle, right? Because Y would be smallest, X would be largest, 12 would be the middle. So that 12 would match in the pink triangle, the middle length there, which is 16. So the ratio of those sides is always going to be the same, which would be, that simplifies to 3/4. And now that's smaller triangle to bigger triangle. So when I'm comparing the 12 and the X from the pink and the blue, the smaller triangle is the pink, which is where the 12 is. So this is the 3 and this is the 4. Wait, I just did that. I set that up all wrong. Hang on. I combined two triangles. The 3 to 4 works, but the X is the largest side in that small triangle. So if I do 3 to 4, I have to do the largest side in the pink triangle. So it would be x over 20. And then I can either cross multiply, or I could just multiply by 5 here and by 5 here, and I get x equals 15. So when you're comparing those two triangles, like the left to the right, to get that 12 to 16 or 3 to 4, then I have to make sure I grab the appropriate side, which on the left triangle is the largest, which is 20, and the right triangle, the largest, which is x. And then when I go to solve for y in that triangle is the smallest side. So I would again do 3 to 4, but smallest side in the first triangle is 12. To smallest side in the second triangle is y. Did I do that right? Hang on, that's not right either. 3 to 4. Oh, I switched the sides, sorry. I'm doing right triangle to left triangle, like literally not right as in 90 degrees, but right as in the yellow triangle. So yellow to pink would be the 3 to 4, so then it'd be y to small side, which is 12. And then again, cross multiply, or this would be times 3, and this would be times 3, and y is 9. So the good news is, test-wise, I kept the triangles separate. They're not like built into one triangle. But when you are doing something like that, like that's probably one of those scenarios in which it would be good to screenshot it, drag it over, kind of be able to draw and manipulate on it. Because even though they're both in that big triangle, and that big triangle is similar to them, we use the two smaller triangles to answer these questions. Okay, here's 18. So same thing here, you've got similar triangles. You have to set up your scale factor. I think this is erased in the wrong spot, huh? You're missing the bottom of 18. Yeah, you're missing that. Let me go back to, this should have been 16. Then you've got enough information to set up your ratio. So the two triangles you can set up are this smaller one and then this bigger one. If it's a parallelogram, remember opposite angles are congruent, so you've got that one pair of angles. And then you've got your proportional sides. So if you look at the black triangle, well, let's look at the pink triangle, x and 15, that would be the longest side. And then you've got, and it looks a little bit close, but I think that 16 is the smallest side of that pink triangle, which means I'm going to pair it with the smallest side of the black triangle, which is 9. So if I did smaller to larger, then it'd be 9 to 16. And then when I go to pair up the x and the y, the x, this is part of that side. So x and 15 would be this long side, x plus 15, would be the longest side, which would go with the 8, which would go with the 15. So 15 over x plus 15 would be how I'd set up that side. And then 9 over 16 would equal the y is part of this side. Oh wait, I need to use the smaller triangle. You can also use the smaller triangle because these would be congruent angles. So that blue triangle would also be similar to the pink triangle because of the parallel lines and the reflexive angle. So once I get here, once I get x, 9, times 16, 240. Holy moly, I'm doing a great job this morning. Wait, let me look back at that. It's definitely the smaller side. make sure you're not missing anything else there. So this is congruent to, where's that other angle? This one. This would be congruent to this one. Okay, so you can use that. Top angle too. Okay, so let's try comparing these two triangles. This one to this one. All right, so if this is 16, right, this is 10 here, then this is 6. That the bottom side of that triangle is 6. So now I can set up the ratio using these two triangles. This one, let me erase this color so we know which one. We're going to compare the black one to the blue one, because those would also be congruent, okay? I mean, also be similar. So now I can do this is, Y looks like it's the smallest side, 6 looks like it's the middle side, and X looks like it's the largest side. So because the smallest is 9, 9 on the black one, 9 goes with Y. Let's try this. And then the middle would be 6 to 10, so 10 to 6. There we go. So this is 54 equals 10Y, and Y equals 5.4. And then to set up the X, same ratio, which is 10 to 6, right? 10 to 6 equals. And now if I want to find X, it's the largest side, so it goes with the 15. So 15 to X. I can reduce this. 5/3 equals 15 over X. And then 5X equals 45, and X equals 9. So it wanted you to compare the two smaller triangles instead of using the large triangle. So ignore that stuff. Okay, this is where it comes from. Like I said before, the good news is that when you're doing this on your test, this is a good application because of the parallelogram. But when you're doing it on your test, they're two separate triangles so that they are confusing as to what side is the longer side, that kind of thing. Okay, then you get to the proofs. So remember in this section, we still only had just angle, so you knew which way you had to prove that the triangles were congruent. But when we get to the next section, we added in the other two. Keep in mind that that's how it will be on your test. You'll have the other two because it's going to be a proof on similar triangles, but not necessarily using angle. So for this one, they gave you angle 1 is congruent to angle 2. You had to put them, and then you had to use J and J because that's reflexive. So that would have been this angle down here. So then this small triangle is similar to the big triangle, and that's angle similarity. And then if that's the case, then you can set up your proportional sides. So you can say something like this, similar triangles have proportional sides. You can say definition of similar polygons or similar triangles. Anything like that would have been fine for that kind of question. Okay, 24 gave you that they're parallel. So if these two are parallel, okay, you can use your alternate interior angles on N and L or on B and C. And you can use your vertical angles. So you only needed 2 of those 3. You could have used N and L, or like this one, you could have used B and C. Either of those is fine. And then again, the vertical angles, you could have used 2 of those 3. Then the triangles are similar. Then you can set up your sides. It's proportional because similar triangles have proportional sides. And then if I want to get to the point where I'm cross multiplying, that reason there is means extremes property. You could also say cross product. Okay, that's the same thing. Books give them different names, but that's the same thing. 26. This time you're dealing with angle bisectors. So if the two triangles are similar and they're angle bisectors, then I can say angle Q is equal to angle H, which is here, angle Q to angle H, and angle QPR, which is this top angle, to this top angle, and that's because similar triangles have congruent angles. Then you can work with the angle bisector theorem. So I could say QPS is half of QPR, and HGJ is half of HGI. That's the angle bisector theorem. Then I can say they equal each other, and that's substitution. So then the triangles are similar, angle similarity, and they have proportional sides. So I can set up those proportions. I think this on level is a little bit harder actually than the one that's on your test. So just because this brings back in the angle bisector theorem. And again, this isn't the only way to do these proofs, but this is just the way the book suggests. Questions on those? Okay, then came 7.5. So 7.5, number 2 is angle similarity. Number 4 is side similarity. And number 6 is side similarity. Eight and 10, we're comparing those side lengths. So 8 is not proportional. 10 is yes. Triangle ABC would be similar to triangle JRT. Or sorry, IRT, yeah. And the scale factor is 4 to 5. You could have also done 5 to 4 because it didn't give you an order on that. 12, back to those proofs. So if they are similar and the angle in between them is congruent, then those triangles are similar and that's side angle side. And then the sides are proportional. And that's the definition of proportional, similar triangles have proportional sides, or definition of similar triangles is fine. So I would say that's a little bit easier than the one that's on your test. That only had like those 3 steps. You only had to prove really one thing. And then the 14, the one that must be true is 3. Angle 1 has to be congruent to angle Y. Questions on that one? Okay. Then came the proof at the end there. So if you had your proportional sides, if those sides are proportional, then the triangles are similar by side similarity. And then you can say angle C is congruent to RAB. And that would be similar triangles have congruent angles, or definition of similar triangles. And then if that's the case, then here's my parallel lines and here's my transversal. If those angles are congruent, alternate interior, then those are parallel. And then 18 said if two quadrilaterals are similar, then the lengths of the corresponding diagonals are in the same, that should be an S there, same ratio as the lengths of the corresponding sides. It said draw and label a diagram, so I just made 2 quadrilaterals, A, B, C, D, and E, F, G, H. And what would have been given is that they're similar. So then if they're similar, all of the angles are congruent, the pairs of angles are congruent, which is step 2. You could have picked any angle. And the sides are proportional, and then if that's the case, those are 2 similar triangles, and then the sides of all 4 sides of the proportionals, of the quadrilateral would be proportional. Questions on those? Okay, then came 7-6. So tell whether the proportion's correct. A is no, B is no, but C and D are yes. Number 4, notice they gave you the whole side length there, so I can do 12 over 33 equals 20 over x plus 20. Or you could subtract the 12 from the 33 and get that this is 11, and then do 12 to 20, 11x. x should have been 35. 6, x should have been 12. 8, x should be 30. 10, x should be 8. 12, the missing side lengths there. AT is 10, NP is 6, AP is 4, RN is 9. 14, RT is 6, and AT is 24, but you cannot find the other 3. There's not enough information there. You needed one more side length. 16, AR is 9, AT is 27, AN is 13, and AP is 39. Questions on those? Yep. No. Well, actually, that's not true. You can get a negative x as long as if you plugged it back in, it would give you a positive side length. So you can't get a negative side length, I would say. So let's say, like, for example, like, look at 10. Like, ignore this one. But if this was on my side length, I could get a negative x there. Because if I plug a negative x into that side length, it would make it go back positive. So this means I can't. The x there means I can't, but the other one would be a yeah. Does that make sense? Yeah, okay. You're welcome. All right, so any questions on the homework packet? Go over those two. Let me go back to it. No problem. All right, so this, again, think back to 7-4. We only knew one way to prove triangles were similar at this point, which is angle-angle similarity. So now it's different. Now we can add in the other two, but for 7-4, we just wanted to use that one. So this says that EAB is similar to what? Notice the parallel marks on this, which means that this angle is congruent to this angle and this to this, making these similar. But the order of the letters is important. So if I did EAB in that direction, I had to do the same for the big triangle, DAC. So this has to be DAC. And the reason there would be angle-angle similarity. Then it sets up the proportion. What over x equals 9 to 24? So 9 to 24 means the top right side, the right side of the top triangle to the right side of the whole triangle. 9 to 24 would equal 6, or sorry, it's going the other way around. What to x? So x is here, which means it'd be 12 to x. So remember the two sides you can chunk up. I can say 6 to 9 and y to 15. But when I use those bottom sides that are not split by those parallel sides, you cannot use just the parts of the sides. So then from here, I can actually say that the next one would be 9 to 24, which again is top to the whole thing, would equal 6 to the whole side here, which is 6 plus y. And then it wants you to solve those portions. So if I wanted to solve 12 over x equals this, 3 goes into both these. This would be 3 and 8. 3/8. I could cross multiply, or I could say this times 4 equals that. So this times 4 would equal 32. And then here, 9 over 24, which again is 3 to 8, would equal 6 over 6 plus y. I can cross multiply, so 3 times 6 plus y equals 8 times 6. This would be 18 plus 3y equals 48. Subtract 18 from both sides. And y equals 10. So, of course, you will be setting up some sort of similarity statement on your test. Of course, you'll be setting up some sort of ratios on your test and then going through and solving those. Jamie, you with us? Okay. Yep. That's okay. If they give you the whole side and they break it up. So let's say, let me show you. Let me erase all this stuff. So let's say instead of let's say you got this. What was this? 10, so this was 16. Let's say they gave you that, right? And you were trying to find this side here. That's when you would be breaking it apart. So if they gave you the whole and you're looking for part of it, and they said like 9 to 15. So 9 to 15 would equal 6 to, this would be 10 minus 6. This would, I mean, let's say that they just gave you this was y, for example, or actually it would be the reverse. More often, this would be x, like something like that, let's just say, right? That y would be 16 minus x if I was looking for that side. Or if I was looking for the x here, like if I wanted to set it up the other way around, then it would be this. Well, this would be 16. Nope, that would be x. You'd have one of those pieces and you'd be trying to find the other part. So only if it gives you the whole and you're trying to break it up into one of these two, that's when you would subtract it. Does that make sense? Okay. You're welcome. Any other questions on 7.4? Answers, yeah. Okay, 7.5, we had our similarity statement. And it says triangle ABC is similar to triangle DEF. Does AB correspond to DE? So AB would match up with DE, and that's a yes. The order of the letters is important. Does BC match up to DE? Nope. Or sorry, to EF, yes. That's a yes. EF, yes. Does AC, which is first and last, match up to DE? And that's a no. So the order of the letters is important. All right, now we've got a proof. It says given angle B is equal to angle DEC, which is given to you, prove that triangle ABC is similar to DEC. We have three ways to prove the triangles are similar now. Angle, angle, side, and side, side. So if you look at this triangle, we know absolutely nothing about the sides, which means I'm probably shooting for angle, angle. They already gave me the first one, which is that angle B is congruent to DEC, and that's what's marked. Now I need one more angle, right, to prove that ABC, which is this big triangle, is similar to DEC, which is the small triangle. So what's in there that you see that we haven't used yet? Good. What would it be if I said angle C equals angle C? Reflexive. Good. So now the two triangles are similar. DEC. And that's angle, angle similarity. I'll tell you this is, again, a little bit easier than what you would see. I would say like maybe another step could be something like trying to prove the sides are proportional. So let's say AB over DE equals AC over DC. That could be like a next step, right? If that's what your proof was. And this would be similar triangles have proportional sides, or definition of similar triangles is fine. You could even go a step further than that and say AB times DC equals AC times DE. And that's the cross product property, or extreme means extremes. Cross product or means extremes. So those are, I would say, variations on what you could see as far as a proof goes on the test. Oh, I did. Okay, so let's go. Chapter 8 is probably like one of the most important chapters in geometry because it's right triangles and right triangles lead into Algebra 2 honors, and they lead into pre-calc, and they lead into calc. So like some of the basics that we're going to talk about, not so much in 8-1. 8-1's kind of the foundation for it, but when you get into 8-2 and 8-3, and we're talking about 30, 60, 90 triangles, 45, 45, 90 triangles, and then SOHCAHTOA, which is like trig, right triangle trig, setting up. Those are things that when I tell you they're not going anywhere, they're not going anywhere. They will be around for the rest of the time you take math, minus maybe in like a statistics class. The rest of them you will see. And I've never seen an SAT or an ACT without a trig question or a right triangle question. So this stuff is super important. So 8-1 just starts, it's called similarity and right triangles, okay? And we set up the right triangles, similarity, so it's kind of like a crossover between the new stuff and what we just did. We start with something called the geometric mean. So the geometric mean is the square root of the product of two numbers. So they set it up as like a proportion to kind of, I guess, segue from what we were just at to where we're going. But if I had two numbers, whatever A and B are, if I wanted to find the geometric mean of them, I could set it up as a proportion, cross multiply, and then square root, or I can just jump directly to it. We're going to square root the product. So if you have two numbers, then the geometric mean is the square root of their product. So we're going to start doing a lot of square roots in this section. When we get into the second half of the chapter, so tomorrow's stuff, you're going to need a calculator that has the sine, cosine, tangent buttons. So it at minimum has to be a scientific calculator. If you, like Eric, I don't know if you brought one. If you don't have a scientific calculator, you can use your phone. You just got to turn it sideways, but it's way less complicated to use a scientific one. So by Monday, you'll be home by Monday, right, Erica? Yeah. And then who said they were going out of town this weekend? Who's going to Universal? Okay. You didn't leave yet, right? You leave tomorrow. Okay. I would definitely bring a scientific calculator with you. So it can be scientific or it can be graphing if you want to start to get comfortable with a graphing calculator. But you definitely want to use one of those. You're gonna need it for a little, like when we do this, obviously this section, you're gonna need it. And then when we get to geometric and probability, you're gonna need it again. So if you don't have a calculator at your house, I know some of you are still under quarantine, you can buy a cheap one, like under $10 from like a Walmart, a Walgreens, anything like that. Amazon, same, can ship it to your house. But you're definitely going to need it for Monday's test, and it's going to be hard to use your calculator on your phone. It gets a little bit complicated. So these are not going to be calculator based. These were going to be kept exact, which means keep it in the square root if it can't be simplified. Example 1 says find the geometric mean of the given numbers. So it's 4 and 20. So A is the square root of 4 times 20. Now here's what you don't want to do. Multiply out the 4 times 20 and then have to break it back down to simplify it. Unless when you multiply those two numbers together, you get an easy square root. Like let's say if it was like 4 and 9, then I can multiply those together. 36 squared to 36 is 6. Unless it's like that, you want to leave them as a product underneath your square root. And then I would take 4 and I would break it down into a product of its primes, which would be 2 and 2. And then I would take 20 and I would break it down so it's 2 and 10, and then 2 and 5. And then I want to look only at the primes at the bottom, the product of the primes at the bottom. So this really is 2 times 2 times 2 times 2 times 5. And the rule on the square roots, as a quick refresher, is that for each pair of numbers, one of those numbers goes to the outside of the square root. So I have 2 2's here, which means 1 2 is going to go to the outside of the square root. I have another pair of 2's here, which means the second 2 is going to go to the outside of the square root. And then the 5 is left alone, and that's going to stay underneath my square root. If there's 2 numbers on the outside, 2 numbers on the inside, wherever they are, you just multiply them together. So this becomes 4 root 5. So you will keep these answers, the words and the directions will say keep them exact. Okay, it will say no decimals. So be careful, don't use a calculator on this one. And when you actually type them in, like if it was multiple choice, it would look like that. But if it's not multiple choice and you're typing this in, it's going to make it 4 SQRT for square root and then 5. So that's how it's going to look on your test when you're typing in these answers. Okay, now look at B. I've got 9 and 25. So if I square root 9 times 25, 9 is 3 and 3, and 25 is 5 and 5. So you can actually bring out 1, 3, bring out 1, 5, and there's nothing left underneath, which means there's no square root here, and the answer is just 15. If I had multiplied those together, I would have gotten 225, and the square root of 225 is 15. So sometimes they're going to be perfect squares, and sometimes they won't. You always want to keep them exact. You don't want to use a calculator to round these at all. Good so far? Yeah, okay. All right, so Theorem 8.1, which doesn't have a special name, you just need to know what it says if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So two things have to happen in order for this to be true. The big triangle has to be a right triangle. So you'll see this has a right angle marked here. It either needs to state it's a right triangle or has to have that right angle marked. And you have to have the altitude drawn to the hypotenuse of that triangle. So remember, altitude goes vertex to the opposite side, forming a right angle. So perpendicular to the opposite side. So you have to have both right angles. If that's true, if those two things happen, if I have a big right triangle and then a small, and then an altitude drawn, then these three triangles are similar. So if I named the first triangle A, B, C, like this is named, remember the order of the letters is important. AB is the middle length side of that big triangle. BC is the hypotenuse. So when I name the other two, I have to follow in that same order. If I want to name this is the one on the right. The middle length side is DB, hypotenuse is BA, so it has to go in that order, DBA. And on the left, middle length side is DA, hypotenuse is AC, so I have to go in that order, DAC. So order of the letters is important. Now they are similar to each other because they each have a right angle and each pair has a reflexive angle. So if I were to compare each of them, they would all be similar. Which means all the theories about the angles and the sides that we just learned are true about them. But we go a little bit further, which is this. Corollary 1 says, when the altitude is drawn to the hypotenuse of the right triangle, so what we just talked about has to happen, right angle and altitude, the length of the altitude is the geometric mean between the segments of the hypotenuse. So there's a lot of words here, and we shorten it with this proportion here. Segment 1 over altitude equals altitude over segment 2. You're going to learn two proportions in this section. So really it's like geometric mean, similar right triangles, and then two proportions, and this is the first one. Segment 1 over altitude equals altitude over segment 2. So if I look at this triangle here, okay, the hypotenuse of that triangle is divided into two parts, this segment and this segment. And it doesn't matter which one you call 1, and it doesn't matter which one you call 2. As long as you set it up so that the altitude of the triangle, which is the thing inside the triangle, is the part that gets repeated. So if I choose this segment, which is segment 1, over that altitude, it's going to equal that altitude over segment 2. Is your screen blurry? Is it blurry on your screen? Yeah, I don't know why it's doing that. Okay. Can you see it enough though? Okay. I don't know why it's so blurry. I think this background is a lot for explain everything and Zoom to handle. Anybody still copying that down? So this is one of the first major things you want to write in your chapter notes for chapter 8. Segment 1 over altitude equals altitude over segment 2. And then obviously what a geometric mean is. All right, corollary 2 says when the altitude is drawn to the hypotenuse of the right triangle, which is the same beginning, so it has to be right triangle, has to have an altitude. Each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg, which is the second proportion that you need to know. Hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. So we actually will abbreviate that, like we use the letters. Oh, delete, go away. We use the letters that are the acronym segment of hypotenuse adjacent to the leg. Some people call it SOHATHL. They just like abbreviate it. It's just an acronym so that you don't have to write that whole thing out. So it's hypotenuse over leg equals leg over the segment of the hypotenuse adjacent to the leg. And what that means is if you're looking at the big triangle, first of all, this right angle was super hard to draw in PowerPoint, so it's not there, but that would have to be there. Or in the directions, it would say something like this triangle is a right triangle, like whatever the name of that triangle is a right triangle. And then you need the altitude, which is what's here, right? That's already there. So we would say the hypotenuse of the right triangle, so this big side, which is C, over the leg. Now there's two legs, so there's two proportions you can set up. If I want to solve for X first, or if I'm given that side first, then that's the leg I'm going to use. So C over X would equal the leg repeats X over the segment of the hypotenuse adjacent to the leg. This segment, or this hypotenuse is divided into two segments, A and B. When we're using X, we want to use A because that's the segment that's next to that leg. Remember, adjacent means next to. That's one proportion you can set up. The other one is hypotenuse, which is still C, that doesn't change, over leg. Maybe now we want to use this leg, Y. That's going to be, again, the leg repeats. So C over Y equals Y over, now the segment of the hypotenuse adjacent to Y is B. So that's what changes. The hypotenuse is always the same, but then depending on which leg you're using, you have to pick the other segment. Okay, so let's go with these. I'm actually gonna duplicate this slide if you want to do the same thing, because I'm gonna write all over it and then I'm gonna need to change it. Okay, or I'm not, because it's not letting me. All right, anyways, let's label it. So for A, I'm going to separate this out. For A, it says JR is 16, EJ is 9, and it wants you to start by finding HJ. Again, this should have a right angle on the top. Okay, so if you're doing this on a test or whatever, that will be the big one will be a right triangle. Otherwise, you can't do any of the stuff we're about to do. So there's two of the proportions we want to use. Segment 1 over altitude equals altitude over segment 2, or hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. The easiest way to identify this is, am I involving the altitude or am I using the leg of a triangle? So if I go off of what we're doing right now, if we just labeled HJ as X, that is my altitude, which means I'm going to use this first proportion, I'm going to say that segment 1, which can be either 9 or 16, it doesn't matter which one, but 9 over the altitude, which is x, equals the altitude, which repeats as x, over segment 2, which is 16. Then I'm going to cross multiply, x squared equals 9 times 16. Now, because I'm going to square root that other side, I'm not going to multiply that product out yet. I'm just going to square root both sides. And I get x equals the square root of 9 times 16. 9 is 3 and 3. 16 is 4 and 4. I can break it down further, but I don't need to because they both repeat. So this is 3, this is 4, and x is 12. So that's the first part. HJ is 12. RE should be easy because that's 9 plus 16, or 25. RH, so I'm going to label this Y so we don't confuse it with the X. Now that Y is a leg. So I'm using the second proportion. The hypotenuse of the big triangle, which is 25, over the leg, which is Y, equals the leg, which is Y, over the segment of the hypotenuse adjacent to that leg. So which of those segments is next to the Y? The 16. So then I get y squared equals 25 times 16. And again, I'm going to keep them separate because I'm going to square root both sides. And the square root of 25 is 5. And the square root of 16 is 4. So this is 20. That's the last. Well, that's RH. And then the last part of A is HE. Let's call this Z. And that's the other leg. So it's hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg, which is 25, over Z equals Z over, this time I use 9 because that's the segment of that hypotenuse that's adjacent to Z. And I get Z squared equals 25 times 9. Z equals the square root of 25 times 9. This is 5 and 5, 3 and 3. I hear you, babe. I know. So Z is 15, which makes HE 15. Okay, so B says JR is 4, JH is 2, and it starts by saying find EJ. So this time I have the two segments of the hypotenuse and the altitude, which means I'm going to use that first one. Segment 1 could be x, doesn't have to be x, but could be x over 2 equals 2 over 4. So the x and the 4 could be switched. So I get 4x equals 4 and x equals 1. That's the first part. RE is this whole segment, 4 plus 1, which is 5. Then it says find RH. So we're going to make that Y. That's on the leg. So I know the hypotenuse. This time I'm using this one. Hypotenuse, which is 5, over the leg, which is Y, equals the leg, which repeats. That's the Y. Over segment of the hypotenuse adjacent to the leg, and the segment next to Y is 4. So I get y squared equals 4 times 5. Y would equal the square root of 4 times 5. 4 breaks down 2 and 2. 1, 2 goes to the outside. The 5 stays underneath. So y, or RH, would be 2 root 5, which is good for homework. On your test, you're going to write it as 2 square root 5. And the last one is HE. So let's put a Z on there. Again, that's a leg, so I'm using that hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. So hypotenuse is 5, over the leg is Z equals the leg, which repeats as Z over the segment of the hypotenuse adjacent to the leg. This time that's 1. Cross multiply, I get Z squared equals 1 times 5, which is 5. Z equals the square root of 5, which is going to stay as square root 5. And if this was on my test, it would just be square root 5. All right, that wraps up 8.1. You're going to watch the video to cover 8.2 and 8.3 and then use that to complete your packet. Have a great day.